Good morning, guys. We are on page 123, the homework from yesterday. Apologize for the chicken scratch on there already. I have to hit record while I'm talking and writing for this to work. So I realized that it wasn't going, so we'll start again. Wants to know the volume and surface area of this prism with different heights. A couple things to make note of. I know I'm going to have to figure out the area of the base, and I know I'm going to need the perimeter of the base to help me with the surface area of the sides. So I might as well figure all that out first. Again, the area of the base, you could split it up into 3 rectangles, add them up. I think it's less work to figure out the area of the whole thing and then subtract the missing piece. So 8 times 5 would be 40 if there was no missing piece. But I do have an area of 2 by 2, which is missing. 2 times 2 is 4, so 40 minus 4. Area of the base is 36. Perimeter of the base, again, that's going to help me with the surface area of the sides. We talked about that yesterday, the one new equation I gave you to save you some trouble instead of doing every rectangle around for the sides. So the perimeter of the base is all these added up. 3 plus 2 is 5. 3 plus 2 is 5. 5 and 5 is 10. 8 and 2 is 10. So I have 10, 10, and 10. Perimeter is 30. So let's do the volume first. Volume's pretty easy. Area of the base times the height. So 36 times 5, height is 5, is 180 cubic centimeters. Second one there, area of the base is 36 times the height of 10. Tells me the height is 10 there. 360 cubic centimeters. Okay, surface area is going to be the area of the base adding to all the sides. So I know I have a top and a bottom. I might as well fill that out on both of them so I don't forget. Okay, plus the sides, area of all the sides. And that's where we're going to use our formula of the perimeter of the base times the height. Okay, so the perimeter of the base is 30 times the height of 5. 30 times 5 is 150. So 150 plus 72 is 222 square centimeters. The height doubles, so 30 times 10 is 300, plus the top and the bottom, the bases, add them up. 300 plus 72 is 372 square centimeters. When the height is doubled, what percent increase for the surface area and the volume? Okay, remember our formula for percent increase is how much did it change divided by the original. Okay, so it went from 222 to 372, so I'm going to subtract that. 372 minus 222 is 150 divided by the original. So 150 divided by the original. And then I'm going to make it a percent. So move the decimal 2 spots to the right. I'm going to say about, put my little squigglies there, 67.6% increase. Again, that's surface area. Okay, how about volume? How much did it change? It went from 180 to 360. That's a change of 180 divided by the original. Obviously there I'm going to get 1. Make it a percent. That's a 100% increase. So when you double the height of an object, this prism, the surface area increased by about 68%. The volume doubled, increased by 100%. Next question, select all the situations where knowing the volume would be more useful than the surface area. So ones that we're going to need the volume for, okay, not the area. Okay, how much paint you need. Anytime you're going to do paint or flooring or anything like that, that is area, that is not volume. Determining the monetary value of a piece of jewelry. Okay, so the area doesn't really matter, but if we were to melt that down and figure out how much gold we actually have, because gold is measured in fluid ounces, okay, how much we actually have, we are going to need volume for that. Filling an aquarium with buckets of water, that one's pretty simple. How much wrapping paper you will need to wrap Mr. Milbrandt's gift, that would be surface area, not volume. Packing a box with watermelons, that will determine how big, how much space it takes up, how much it goes inside of the box, so that is volume. Charging a company for an ad on your race car, that is going to be surface area again. And how much gasoline you have left in your tank is volume. Question 3. We have a 50, a 40, and a side length 4. Can you draw a different triangle? So can I, with this information, draw a different triangle? Well, let's try it. I think this is in centimeters in the middle here, so I'm going to start with 4 centimeters on the bottom. And I am going to make a 40-degree angle to start. So this would be 40 degrees. Let's make a perfect 90 this way. Make a little note that that's 90 degrees. That means this would have to be 50 because they have to all add up to 180. These two would be complementary, however you'd like to look at that. So I do have a 50 and a 40 and a side length of 4. Is that the same or different than the first one? Well, let's look where the 4 is. Here the 4 is across from the 90. Here the 4 is across from the 50. So those are different. So can you draw a different triangle? Absolutely. Problem 4. Angle H is half as large as J. Okay, so to get H, I gotta take half of J. J is 1/4 of K, so 1/4 times K is K, and it tells me angle K is 240. Fine. So angle K is 240 degrees, J is 1/4 of it. So what is 240 divided by 4? Should be 60. So J is 60. H is what we're looking for, is half of J. J is 60. What's half of 60? H is 30 degrees. Okay, the final question. The Colorado state flag consists of 3 horizontal stripes of equal height. Side lengths are 3 and 2, ratio of 3 to 2. So let's say this side is 2, this is 3. The diameter of gold centered disc is equal to the center stripe, so we got to figure out what that is. What percent is gold? Obviously, a small percent of that flag is gold. So I got to figure out the diameter radius to get the area of that circle. Remember, area is pi r squared of a circle. So if I have 3 stripes and the whole side is 2, what's 2 divided by 3? And I'll just leave it as a fraction. 2/3, 2/3, 2/3. So that means my diameter of the circle is 2/3. How do I get the radius if I know the diameter? I got to divide it by 2 or take it times a half. So 2/3 times a half. 2's cancel. So my radius is 1/3. So my area of a circle is pi, and we can just round it, that's fine. We're going to go 3.14. 1/3 times 1/3 is 1/9. So pi divided by 9, 3.14 divided by 9. So my area of a circle is about 34.89. Sorry. 0.3489. Okay, so that's my area of the circle. And I'm going to divide that by the area of the whole flag. What's the area of the whole flag? 2 by 3 is 6. So I'm going to take that number, and it's going to be more exact because I'm not even going to use this. I'm going to use the exact number of my calculator, and I'm going to take it divided by 6. So I get 0.05814, approximately. Move the decimal 2 spots to get a percent. I'm going to say about 5.81% of that flag is made up of the gold circle. All right, that concludes the homework for lesson 15. Take care, guys, and we will talk to you soon. Bye-bye.